All right, we're going to prove triangles are similar by side, 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 and side, angle, side. So before we get started, let's do this warm-up. Okay, so I've got this equals this, so I need to do distributive property with the 2 and distributive property with the -3. So then I end up with 2x plus 16 equals -3x times -9. Make sure your signs are correct. And the first thing I'm going to do is I'm going to add 3x on both sides. Since that's minus 3x, we need to add 3x on both sides. And that'll make this go away. And then I've got 2x plus 3x is 5x. Okay, so now I need to subtract 16 on both sides. And then I end up with, and that'll make that go away, and then I have 5x equals, and -9 and -16 gives me -25. And then the final step is we're going to divide both sides by 5, and then we end up with x equals -5. Okay, so this is very important, this next step. So you're given that these triangles are similar. This little squiggle sign means similar. Okay, so if you see the letters QR first and XY first, that means QR and XY are going to be similar with their ratio. So if I set up the ratio, I'm going to write QR over XY. So the ratio of this side and this side is going to be similar. They're not congruent, but the ratio will be similar. So the next two letters here are R and S, and the next two letters are Y and Z. So I can say RS and the length of YZ are going to be similar. So if I write the ratio here, I'm going to end up with the length of RS over the length of YZ. That ratio should also be similar. Okay, and finally, the first and the last is QS, and the first and the last is X and Z. So those ratios should be equal too. So the ratio of QS over XZ. So if I knew this line and this line length, I could create the ratio. Or if I knew this line length and that line length, I could create a ratio. If I know this length and this length, I can create a ratio. And all of those ratios should be equal. And if they are, then it is similar by side, side, side similarity. You may want to watch this video again if that make it make sense. If you don't need to. But okay. So let's talk about side, side, side similarity. So notice here the shortest side, which triangle is similar to ABC? So the shortest side here is 7. So the shortest side here is 6, and the shortest side here is 3.5. Okay. Let's see. The longest side is 12. The longest side here is 11, and the longest side here is 6. The middle side is 8. The middle side here is 7. The middle side here is 4. So which of these two triangles is similar to this one here? So we need to set up the ratios. So 7 over 6, is that equal to 12 over 11? Okay, so I can get my calculator out. What is 7 divided by 6? Okay, and then what is 12 divided by 11? No, those ratios are not equal. So So this one is not similar to this one here. How about, let's see if the ratios of this are, so 7 over 3.5. Is that equal to 8 over 4? Well, first of all, I know 8 divided by 4 is 2, right? And 7 divided by 3.5 is, oops, you may have already known that, is 2, and is, what's the other number? 12 divided by 6, that is also 2. So we know that the ratios all equal 2. Every single ratio is the same, so it's similar by side, side, side similarity. Okay, let's do the next one. Now in this example, you're told that they're similar. So if you know that they're similar, then let's look here. So the longest side in the picture is this one here, the 3x minus 1. The longest side in this picture is the 7.5. Okay, the shortest side on this picture is 8. The shortest side on this picture is 4. Okay, and the medium side on this picture is 10. And the medium side on this picture is x minus 1. So I could set up the ratios anyway, since the variable is x. So let's set up the ratios with 8 over 4 equals 10 over x minus 1. Okay, so I'm setting up the ratio of the smallest sides, which are the blue ones here, and I'm setting the ratio of the second smallest sides, which are highlighted in pink. And I could have set up the ratio with the yellow sides and the blue ones as well, and either way would have worked. Okay, so let's solve. Okay, so I could cross multiply here, and we end up with 8 times x minus 1 equals 4 times 10. And you should be able to notice right away that 4 goes into 8 2 times. So then I have 2 times x minus 1 equals 10. And now I should do distributive property. And then, so if I do distributive property, I end up with 2x minus 2 equals 10. And then your final step, well, I guess not final step, but now I need to add 2 on both sides. And then I've got 2x equals 12. So if 2x is 12, divide both sides by 2, I get x equals 6. All right, almost done here. Okay. Okay. Side, side, side similarity is if you have two side ratios that are the same and then the angle in between is congruent, then the triangles are also going to be similar. So are these two triangles similar? Question mark. Okay, let's figure this out. Okay, so the shortest of these two sides is 2. Okay, what is the shortest of these two sides? It would be 8. Okay, the longer of the two sides is 3. The longer of the two sides is 12. So, first of all, what is the ratio of 2 over 8? Okay. And then, is that equal to the ratio of 3 over 12? Well, let's see. I could do, now you should already be able to notice this is 1/4 and this is 1/4, but if you didn't recognize that, I could have said 2 times 12 equals 3 times 8. Well, what is 2 times 12? That is correct, it is 24. And what is 3 times 8? 24. Are those equal? Yes. And since the angle in between is congruent, we can say, therefore, 3 dots means therefore. Therefore, the triangles are similar by side angle side similarity. All right. Have fun with your notes.